Right, beta radiation. What is beta radiation? Well, essentially, if you've got an atom that is overweight, that is unstable because it's got too many neutrons, one of those neutrons will change into a proton and an electron. And it is the electron that gets thrown out of the nucleus quickly, because you can't have electrons in the nucleus. It gets thrown out very quickly. The electron escapes the atom, and it's the electron that is the beta particle. It's a fast-moving beta particle. It travels at roughly 90% the speed of light, which is about 150,000 miles per second. Probably a bit more than that, actually. So it's about 160,000 miles per second. So it's a very, very energetic particle. What happens is that because you have increased the number of protons, the proton number goes up, and the mass number stays the same because you've got the same number of protons and neutrons added together. The beta particle is a very fast-moving electron, 90% the speed of light. It's got a charge of -1 and an atomic number of -1. It's got negligible mass. It's basically 1/2000th the mass of a proton or neutron, and it's ionizing. It's not as ionizing as alpha, and it's more ionizing than gamma. It can be stopped by 1 meter of air, a thin aluminium sheet. It's not stopped by paper or skin. Right, first of all, it is dangerous because it's ionized, which means that it can knock off electrons off DNA and cause cancers. Basic ionizing means it will actually cause it will wreck atoms to actually make them positive or negative. The danger with beta is that if you have it outside your body, the beta can penetrate skin and cause damage inside your body. And also, if you breathe it in, it's like to do a lot of damage to your body. If you have particles, if you have a radioactive substance that's giving out beta inside your stomach or intestines, it's very dangerous as well. Right, magnetic fields. What you need to know is basically the beta particle curves in a different direction to alpha particles. That's because the beta is negatively charged and the alpha is positively charged. And the effect in electric fields is that the beta particle is attracted towards the positive plate. If you've got two sort of steel plates and you give them charges, one a positive charge and one a negative charge, you'll find the beta particle is attracted towards the positive plate. And it's one of the ways we know that beta particles are negative. Here's a formula, and what I'm trying to show here is carbon 14 changing to nitrogen 14. And if you notice the top number, which is the ones highlighted in red, it's got 14 is the mass of the carbon atom, and if you notice 14 equals 14 plus 0, because you say beta's got no mass to it really. If you notice the bottom though is probably a bit more tricky, is you had 6 protons. It's gone to 7 protons and nitrogen, and so therefore the beta has a -1, because basically everything in green must add up. 7 add -1 is going to be 6. So you must make sure those numbers add together. And the clue for that is, you tend to see this as a question in exams. They may show a beta as a beta particle. They may even show it as an electron with a symbol E. Here's another example there. This again is showing hydrogen changing to helium, and you can, by giving off a beta particle, and this time you see we've used this E symbol to represent a beta particle. And again, the numbers do add up. 3 equals 3 plus 0, and along the bottom, 1 equals 2 minus 1. Right, the key words that you need to know is that, or key concepts, is that neutron basically beta particle emission is when a neutron turns to a proton or electron. The beta is very small. It's got a charge of -1. You must know what we mean by ionizing. In other words, it causes atoms to become charged. It can be stopped by aluminium. You need to describe as to how it's affected in electric fields and magnetic fields. And you must be familiar with the formula we just saw a minute ago. And that is beta radiation.